if you've got a rod in the hand and you fished today and you had a great fishing trip, you want to have the same fishing trip in 10 years' time, correct? So, the ultimate goal is that fishing will happen forever at the same level. That's sort of the genesis of what we're trying to achieve.
This is Fish Tales, a seafood podcast. I'm John Susman.
Two of the most common characteristics of scientists are curiosity and patience. Scientists are curious about the world around them and they yearn to learn what makes everything work. Their inquisitiveness keeps them going ahead to the next project and the next experiment. Scientists need to be detail-oriented, noticing every tiny observation and remembering and recording them. They usually have facts and hypotheses from several fields and experiments tucked into their memories so that they can be put together in different combinations to answer questions or provide direction for research. Often, this intense level of discovery makes science and scientists somewhat dull. Patrick Hone, Managing Director of Australia's Fisheries Research and Development Corporation, or FRDC, is an exception. Patrick is a science evangelist, a patient and curious man who uses his love of seafood and passion for science as the means to drive the Australian seafood industry, both recreational, commercial and Indigenous, to achieve the most sustainable and equitable outcome it can, for both the industry, for consumers, but mostly for lovers of the marine environment.
My name is Patrick Hone. My current role is the Managing Director of the Fisheries Research and Development Corporation, a national body that overlooks a significant proportion of the research that underpins the amazing fishing and aquaculture sectors. Like a lot of people, I fell into it. You don't expect to be, maybe, when you leave school, to end up in a long-term career in fisheries and aquaculture. Like a lot of people, as a young kid, I loved anything to do on the water, whether it was spending lazy days on the Murray River, water skiing, or if it was snorkeling off Port Wollonga Beach, or whether it was going fishing with my dad. As a young kid, I just liked to be on the water. When I went to university, just loved maths and I loved biology and I loved science, but never really thought I'd end up at that time in fisheries. I think I was just fortunate in the 80s when I was getting my science degree. Fisheries was going through quite a transformation in the types of scientists they wanted, and they wanted more quantitative scientists who understand maths and physiology and some of the newer sciences and computing science. And for a young scientist who wanted to be really challenged, it was a great place to go because, when you look at the world of science and you look at the great challenges of the world, we have one of the most intractable, wicked problems, which is counting something you cannot see. You cannot see through the water. And it is such a difficult problem. And when you start sitting down and you start doing, life histories and you start doing year class analysis and you try to extrapolate back from a catch to understand what the actual original catch is, and you start doing the maths of it, and it gets quite exciting that every new scientists come up with new methods and new ways of solving this really complex problem.
The Fisheries Research and Development Corporation takes a leading role in planning and investment in the science surrounding Australian fisheries, specifically through the funding of research and development in Australia to ensure the ongoing sustainability of our marine sectors and marine ecosystems. The FRDC plans and invests in fisheries R&D activities in Australia, facilitating the research and curation of the science needed to inform government about the status of commercial, recreational and Indigenous fisheries. If there is an agency in seafood whose sole mandate is to have an intimate and fact-based relationship with the resource, it is the FRDC.
What is FRDC's role? At the courses, people could say, oh, you're a bank and you've got money and you grant money to people and people do things with that money to answer questions. So, that could be the simplest thing, is that FRDC is an investor in research. But we see ourselves much more than just an investor. We feel we have a stake in an outcome. We're very goal-driven. We work in an applied science, so our goal is to actually answer questions, not just questions that are today's questions, but tomorrow's questions. And that requires FRDC to be really thinking about foresighting and scenarios and end-driven thinking towards, various parts of the next decade in terms of the types of science that we might need to make sure that our industry continues to be competitive and productive and deliver the sorts of values that people want. And so, FRDC has many roles. I often say that probably the easiest way to say is FRDC is a facilitator between people who've got great ideas and people who might be able to help find solutions to make their ideas.
Fisheries science is the academic discipline of managing and understanding fisheries. It is a multidisciplinary science which draws on many disciplines including oceanography, marine biology, meteorology, conservation, ecology, economics and fisheries law. Because fisheries science is such an all-encompassing field, fisheries scientists often use methods from a broad array of academic disciplines. Fisheries scientists are a unique mob. From my experience, they're universally passionate about the environment and always in pursuit of the truth over fame.
I often say, when young people ask me about a career, I say to them, fishing aquaculture offers everything, because it's people often think that fisheries science could be quite one-dimensional. Maybe all we're interested in is understanding the biology of a species, but that's far from truth. We have to understand the environment, so we have to have an environmental science. We need oceanographics people. We need meteorologist people. Just trying to understand the aquatic environment needs a great understanding of water chemistry, mathematics. And then we start to go into some of the other disciplines that we look at, across the science framework that we've got. More and more these days, we've got a high percentage of the people working for us are social scientists. Social scientists comes in many, many different types of forms as well, just like biological scientists. And they play a really important part, because a significant part of what we do is all about capturing the behaviour and understanding about how people want to interact with aquatic environments. So that understanding that behaviour has many dimensions to it, and so having different types of social scientists is really key. Connected with that, of course, is other science, like people who are into geography, people who are interested in economic science. And these days, we're in part of the digital revolution. Here we are talking on a blog, but across the whole fishing and aquaculture sector now, everyone is doing digital work, whether we're using satellites, in-water digital, digital across the supply chain with traceability. So there's so many different aspects to fishery and aquaculture science, and it's just expanding all the time. And I think one of the really exciting things, looking to the future, is just how many new careers are coming online that are going to be really quite revolutionary in how we actually can improve the outcomes for people who want to be part of the aquatic environment.
Fishery management aims to preserve the economic value of a fishery, usually by implementing a set of regulations that will lead to an economically beneficial but demographically sustainable harvest of a desired species. In Australia, fisheries management is underpinned by evidence-based science. Australian fisheries are scientifically monitored, regionally managed and legally enforced.
Fisheries management is, for a lot of people in the general public, is sort of hidden under a mushroom, so to speak. A lot of people don't understand that we have what we call managed fisheries. The basis of managed fisheries is that they have to have evidence to actually inform certain decision points in a management platform, if you think about management. A simplest thing could be, let's say, we want to try and make sure that we've limited the catch, and so we've got many things we might do to do that as a manager. And one of those, for example, is we might say we want to put a bag limit on a particular species. So how do you set a bag limit? Well, the only way you can do that is to understand certain science that can inform what would be an allowable catch to make a bag limit a reasonable catch and still allow that fish species to continue to populate and be biologically sustainable. And that's the sorts of science that, we have to do in fisheries management. It's very unique in terms of fisheries science in that almost everything that's done in fisheries management has to be done by evidence from science, which there is very few occupations in Australia where there is such a strong linkage between the science and what happens in someone's day-to-day activity when they go around their business, whether it's a recreational fisher, an Indigenous fisher, or a commercial fisher. At the end of the day, they all have to do it on a basis of science.
The hardest part of fisheries management lies in the number of stakeholders. From recreational and small-scale Indigenous fishermen to large-scale vessels harvesting and processing thousands of tonnes of fish, there is a broad range of demands, expectations and needs. Providing science which supports all stakeholders is a unique and very tricky task.
It's tricky. And I don't say we ever get it right because it is so broad. We've obviously got distinct populations or people who act in different parts of the business that we work in. And each of them have different ways that you have to interact. Some of it can be highly regulated. So in the strictest fisheries management sense, as you know, in fisheries management, we have a whole lot of process-orientated ways in which information and decisions are made, which would either inform a management agency or, in some cases, the minister. And those processes are sometimes as prescribed in legislation. There's just requirements of certain processes to happen. And FRDC has to interact into all of those processes. In other areas, it's not quite as prescribed, where we're doing what we call the co-management component, where we're trying to do more what we call the community-led or the industry-led science, where people are doing voluntary science to inform voluntary decisions about how they want to work on the water. And I think more and more, as we've modernised the fisheries landscape, we're trying to deregulate and make it much more user-driven, co-managed, designed, so that the people who are actually on the water taking part of the catch or maybe releasing the catch or whatever they're doing with the fish species have more direct influence in how decisions are made that influence what they're doing. But just going back to the groups, there's over 5 million rec fishers. There's some 30,000 people who work in the wild capture group in various elements. You've got the supply chain, as you know, all the way through to the woolies and coals. You've got many, many peak bodies in our industry where we've got a plethora of peak bodies. And, the really nice thing is that we've got some really strong, high representation groups like Seafood Industry Australia that can coalesce and bring together a whole lot of people in a conversation, so we don't have to talk to as many. Indigenous is quite a struggle for us because by the nature of the way the different mobs and different communities interact, you have to do a much more devolved model of communication with them. So it is a complex communication story, and the channels of communication have to be, bespoke to each of them.
Social and environmental justice are issues in nearly every facet of society. Fisheries are no different. It is important that something as polarising as the seafood sustainability debate is based on facts and presented in a balanced manner. Sustainable seafood is the most environmentally efficient source of protein on the planet. Both wild capture and farmed fish are essential for ensuring sustainable supplies of seafood are available for our country and the world. Our laws, underpinned by the commercial imperative for both wild catch and aquaculture businesses, demands that seafood which is caught or grown in Australia is done so to the highest levels of sustainability.
Look, John, I think the easiest thing is if you've got a rod in the hand and you fished today and you had a great fishing trip, you want to have the same fishing trip in 10 years' time, correct? So, the ultimate goal is that fishing will happen forever at the same level. That's sort of the genesis of what we're trying to achieve, which is that intergenerational thing that, our children and their children will enjoy the same fishing experiences as our grandparents enjoyed. At the end of the day, that's what you're trying to achieve in sustainability. And so that's at the heart of it. as scientists, we break that down into a whole range of numerical tools to try and understand how that can be overlaid in terms of the what we call the target stock or the fish stock that the particular group of people want to actually interact with. And that's where it gets more complicated in terms of a definition of sustainability. I always struggle. A lot of people would like to just put a number on it. You should never fish below 48% of the original virgin biomass, or you shouldn't go below a certain 60%, or, you should never fish a Murray cod over 100 centimetres. I think if you'd come up with blanket numbers, you don't reflect either the environment the fish stock lives or the biology and life history of that fish stock. So to me, one of the real challenges for fisheries science is actually taking that individual nuancing of each environment and fish stock and actually being able to convert that into meaningful sustainability goals for each of them.
Is there a food ingredient in Australia right now that has been subject to a greater level of scrutiny than Atlantic salmon? The kangaroo court, run by a segment of the population who deny the science and laws that stand behind the production of this dynamic aquaculture industry, are disappointing and inconsistent in regards to the needs of modern Australians. Generalisations or cherry-picked information can too easily be used to bias a debate. From where I stand, I believe the fisheries science of the salmon industry deserves to be respected.
I eat Atlantic salmon. I also eat ocean trout. I love freshwater trout. And I wouldn't eat or talk to my friends about eating salmon if I didn't think it was a sustainable industry and also an incredibly healthy thing to eat. So with that rejoinder and just declaring a conflict that I love to eat Atlantic salmon, let's talk about the science of how we ensure that we've got the right settings for how we farm salmon. Well, the first thing to remember is that it's in introduced species. And so as soon as you start farming introduced species, you have to be conscious of the fact that you don't want to impact on endemic species, native species. So a lot of work has gone into making sure that when we think about farming a non-native species, that we're doing it in a way that won't interact with the native species. So that's a whole area of science we do. The second thing is we want to make sure that when we put a salmon farm in the water, that the footprint is incredibly small. In other words, the footprint is at the size of the farm. And it's a bit like looking at a vineyard and saying, there's the vineyard, but as soon as you cross the road and there's a native forest, there's no more vineyard. It would be the same in the ocean. When you look at a salmon farm, there's the salmon farm, but just outside the salmon farm, we want the environment to be as natural as it can possibly be, given some of the other things that might be infecting the environment around salmon farms. And so to do that, we have to have a really good understanding about the husbandry of the salmon, the life histories, the biosecurity requirements, the year class of the salmon that are going in, how we're going to actually plan the production cycle for a 365-day year in terms of how we want to make sure that we've got fish coming out of the farm on that regular annual cycle. And using that information, then we put that into various environmental models that we've developed for different regions, and we can come up with a really good understanding about what are the biological limitations about how much salmon we can put in the water. Then Australia does something that's quite unique in the world. We're incredibly conservative. And we're conservative because, first of all, we're growing Atlantic salmon in some of the warmest waters for salmon grown in the world, because we're not growing them up in the Antarctic, cold waters of the Northern Hemisphere. Tasmania, while it's a cold water area, still is quite warm for Atlantic salmon growing. And so we've got to take an understanding about that the environment that they're growing in and make sure that we're comfortable that we've got some resilience in there so that we grow our Atlantic salmon at much lower stocking densities than the rest of the world. The next thing we want to make sure is that when we feed them, that the majority of the feed that we feed actually ends up in the salmon and not in the environment. And that means we need to design feeds that go into the salmon to be highly digestible. So in other words, when they eat it, they use the whole feed, and that as little of that feed actually ends up as feces or comes out as dissolved materials through their gills. So we're very keen to and if you think about it from a fish farming perspective, the higher utilisation of the feed is actually good for them. They're actually going to have a higher profit because it's actually being used and not wasted. And so designing those feeds and making sure part of that is understanding if there is going to be nutrients lost from the salmon, that we understand what that nutrient loss is, and then understanding if there needs to be a cap in that receiving environment so that the amount of lost nutrients is within a cap. And a lot of people don't know that in Tasmania, for example, when Atlantic Salmon's farm, the Environmental Protection Authority puts in nitrogen caps in each of the receiving environments as a region. And part of the science is to make sure that we understand how much tonnage of fish can be farmed in an area so it won't exceed that tonnage cap, because we're trying to keep the load in the environment at extremely low levels so it's not detectable. The really nice thing about this is it's while we talk about models, fish models, I was talking about the salmon models that we developed to try and inform these decisions. We actually then go out in real time and actually take samples. We take sediment samples, water samples, samples off the nets. We take fish samples. We go a long way from the farms and we take samples. And so we actually then get a very strong measure of actually what's happening to make sure that what we said would happen actually does happen. And then that gets put back into the whole decision making, because much of this is what we call adaptive management. You cannot expect every fish farming year to be the same as the last one, because the environment changes every year. And so to make sure that we're continuing to adapt all of the settings that we've got every year.
One of the challenges of fisheries science is the sheer scale of the research needed. Where a terrestrial food scientist may be a beef, chicken or pork scientist, a fisheries scientist can be charged with investigating thousands of different species in thousands of different environments. Fisheries science can be as challenging to define as it is to execute.
If we had just stuck to 4 or 5 species, I could have my feet up on my desk every day. When I look across the hundreds and hundreds of species now that are either caught for angling pleasure or people now consume in restaurants, and not just eating the fillet anymore. Now, people like Josh Nyland are challenging us to eat the whole fish. It's just amazing to see the breadth and quality and the change in happening across those species. That's brought enormous challenges to fisheries because, of course, people, things that we used to throw away are now almost, like the money fish for an angler or the money fish for the commercial fisher. And you only have to look at aquaculture. 30 years ago, people used to talk about Murray cod aquaculture, but gee, sit down and have a plate of beautiful farm Murray cod these days and you'll think you had the best meal ever. So, it's just rapidly changing all the time. And I think that's fantastic for everyone that we've got such a diversity of offerings. I often say, I feel sorry for the sheep industry or the dairy industry because they're so one-dimensional. We've got such diversity. We've got crustaceans, we've got finfish, we've got mollusks, we've got echinoderms, and within each of those are just phenomenal. And as you know, there's now got the new seaweed revolution, and seaweed offers so many new plant-based opportunities to bring plant-based foods into seafood offerings, and also provides other things like decarbonising the environment. So yeah, it's just phenomenal, the opportunities coming out of the aquatic environment at the moment.
Science should inform policy, determining whether or not we should fish a population and under what guidelines. That policy then creates management, the rules and regulations set in place and their subsequent enforcement. For Patrick Hone, the next generation of researchers, managers, fishers and consumers are key to how and what the role of the fisheries scientist becomes.
I'm very excited. I almost say we've got the renaissance in fishing and aquaculture happening right now. it's changing so rapidly. I would say it's changing for lots of reasons. I would say it's changing because our fishmongers, our cooks, our amazing chefs, our retail sector are really changing their appreciation of the seafood product. In the recreational sector, we've got a young breed of new angler coming on who, we're trying to get young people into our industry, and these young people are coming in with really exciting ideas about how they want to be part of the, recreational angling community. And the Indigenous sector is just absolutely going from leaps and bounds where they're trying to evolve a model of maintaining their cultural heritage and at the same time modernize that to develop regional values for their communities, including economic values, so they're very important to them, but also maintaining those cultural values. And, the changes that we are seeing in our industry are probably the fastest we've ever seen, ever over the decades of fishing. I love the people. I like the interactions. I like solving people's problems. I like getting up at the day and working with an amazing team who are incredibly focused on working with a wide range of people all around Australia. I love the challenges. I like the fact that, we're very end-focused in terms of making sure that we can solve people's challenges. I like the fact that people probably don't realise that, the fishing aquaculture is an incredibly rewarding group of people to work with. We've got our characters, and we do have, occasionally, I often say it'd be nice to have peace in our time between the different sectors. But, while we have our occasional clashes and differences of opinion, we all have an abiding love about having healthy aquatic environments. That's what unites us. We all love just healthy marine and freshwater systems, which is the thing that unites us. And so, the thing that gets me up every day is the fact that, I think science can make a difference. And I do think we do make a difference. And I'm very proud of the things that we do around Australia. I think sometimes we would like to feel that we're getting that information out in a more timely fashion to make sure that we're more modern in the way we can get our information out and make it more easily translatable, easy understanding. I really struggle with a lot of the negative components of what happens in science these days. John, you mentioned the salmon. It seems that a lot of these days we spend a lot of time debunking myths or arguing on things where there is really no argument. The science is already there. But we keep having to say the science 20 times, but there's other people who have different views. And I get very disappointed when, for example, people say X and I go, well, that's, we debunked that 20 years ago. Why are we still talking about that?
Often, when it comes to decision making, people want to be told what the outcome of the various choices will be. Science-based decision making just isn't that straightforward. We can use models and mathematical equations to predict various outcomes, but we can't guarantee the results. That's the role of the interpretive scientist. Patrick Hone is a rare and unique species in the seafood industry, an eternal optimist, devout seafood enthusiast, and inspirational leader. Patrick has been stewarding excellence in fisheries science for over 3 decades and continues to motivate, inspire, and lead without fear, favour, or prejudice. He is a true star of the sea. This is Fish Tales, a seafood podcast. A Deep in the Weeds production. I'm John Susman. Follow us on Instagram at Fishtails Seafood Podcast or email us at fishtailspodcast@deepintheweeds.com.au. Stay tuned for more tales from beneath the surface of the seafood world every Friday on your podcast app.